Hi, welcome to MwalimuPLUS live classes. This is the only platform that gives you the key to unlocking your potential. Actually, your potential here is your talent. This is also the platform that helps you to understand, because our information is actually broken down into very simple material which you can enjoy and understand. My name is Peter Moguche. This is grade 5 mathematics. Now, I just want to take you through what you had covered previously. That is, in the previous lesson, we see what we had covered, and then we link that one with what we are going to cover today. Now, we were talking about volume, and in volume, we were talking about volume of cubes and cuboids using the formula. Even before this, we had looked at how we can come up with the stacks by putting maybe unit cubes to form the base. Then we continue forming them up in terms of layers and come to form a whole cube or cuboid. Then later on, I introduced you to now how we can calculate the volume by finding the space inside a cube or a cuboid by looking at the sides that are making up a cube or a cuboid. And at the end of that, I left this question behind for you to attempt. And the question here is, Kapul compared the volume of two different containers, as you can see from those two diagrams. Then the question was, what is the difference in their volumes? So you are supposed to, first of all, to look at those containers that are given. Then you identify them. Are you able to see the difference between container 1 and container 2, or the container above the other one that is below? You realize that the above container that measures 20 by 15 by 8 is rectangular in nature, while this one here that is measuring 12 centimeters is actually a cube. So that difference will actually help us so that we can calculate the volume. So having identified those, then the next thing we need to do is to find the volume of each container separately. And this is what we do. We start with the first container, the one that is rectangular in shape, and then we find its volume. Remember, I said if you want to find the volume of such a figure, that rectangular container, first of all, note where we have the longest side. Remember, if you want to liken this with what you covered before, then this becomes the column. Then along the width is where we have the rows. Do you remember what we used to count on the rows and the columns before we counted the layers? If you have that idea, then this becomes very simple. So on this very particular side of the column, we had 20 centimeters. Then where we have the rows, exactly that is where we have the 15 centimeters. And then along where we normally have the layers, that is where we have our height. So we are going to multiply the length by the width first, which is actually 20 centimeters by 15. What is 20 centimeters by 15? To make it very simple for you, just take the whole number 15, then multiply by 2. What do you get? Of course, you get 30. Now, you had left a 0 behind, so bring that 0 to 30 and you'll make 300. And because we are talking about just what we are forming at the bottom or where we normally have the first layer, then that becomes the area, and that is now 300 square centimeters. Now you take this area and then you multiply by that height, which is 8. So in other words, 300 centimeters by 8 centimeters. And what do you get? Very quickly, and there you are. It is 2,400 cubic centimeters. Volume is normally given in cubic centimeters. That is the first container, the rectangular container. Let's move to the next container. The next container was a cube, and you realize that a cube has got all its sides equal. Therefore, the length, the width, and even the height will all have the same units. So, if one side is given as 12 centimeters, then the other two also should measure 12 centimeters each. In other words, now we are going to multiply the same number in 3 places: in the length, in the width, and in the height. So take the first two that make the base, that is 12 centimeters by 12 centimeters. Length times width, or simply call it side by side. And because the sides are equal, therefore we're going to have 12 by 12, and that will give us 144 square centimeters, because the base is composed of only 2 sides, the length and the width, and that is area. So once you find the area at the bottom, then you multiply this area by the height that you have. And what was the measure of the height? Of course, the same, 12 centimeters. So here we have 144 square centimeters multiplied by 12 centimeters. Now, what is 144 times 12? You take that and multiply the usual way, that is vertically, 144 times 12. And what do you get if your working is right? You'll get 1,728 cubic centimeters. Now, 1,728 cubic centimeters is the volume of now the cube. Now, I want you to keep this in mind, and you also remember what you had in the first container. Now, the last part of the question was asking us to find the difference. And the difference here is actually you subtract one from the other. Now, this is what you do. You take now the difference. Remember, the first volume was 2,400 cubic centimeters. Subtract 1,728 cubic centimeters. When you subtract that, very simple, vertically, you'll get 672 cubic centimeters. That's the difference between the two containers. Now, having seen this, then we introduce ourselves to the next lesson, which we are supposed to do today, and then we see if there is that link between the previous lesson and this one here. We are still in capacity, and we are talking about conversion of milliliters to liters and vice versa. Do you see any link, any correlation? Are they related in any way? You realize that, first of all, volume is that space. Then, if we put some liquid, say water, into that space we call volume, then what we are finding is simply capacity. So in other words, these two are related. So let's start by looking at the introduction. What is capacity? For us to understand capacity, we need to have containers of different sizes. I want you to look at the diagrams that we have. The first set of containers is actually small bottles. You can see some are smaller than others. So some are very big. In fact, the very first one is very small. Then, if you start from your extreme right, you'll see that the containers are small and then gradually become bigger and bigger as you move towards your left, except now the very last bottle that has the smallest or the same capacity as the first one, or the same volume as the first one. Now, you move down a little bit, you'll see some other bottles which are very familiar to the environment where you stay. These are a little bit bigger. They are still bottles, but bigger than the first set of containers. Now, how do we measure capacity? Unlike volume, where we talk about cubic centimeters, after multiplying a length by a width by a height, here we talk about how much goes into that space that you called volume. And therefore, the units here usually are liters and milliliters at your level. But I'll introduce deciliters in case you'll need it somewhere. But for now, we are going to look at liters and milliliters. Now, the two containers that you are seeing there are actually 1 liter. So that bottle is 1 liter. And then the next one is 250 ml, milliliters, which is approximately a quarter of a full liter. We are going to see this as we move on. Now, moving on, we also need now to know the relationship between these two measures, liters and milliliters. How are they related? Which one is bigger and which one is smaller? So, looking at 1 liter, 1 liter is equivalent to 1,000 of the milliliters. So you need 1,000 milliliters in order to make 1 liter. So that bottle that is written 1 liter is the same as carrying inside there, the smaller units, milliliters, 1,000 of them. Then half a liter would actually half of 1,000, and that is 500. Quarter of that will actually mean quarter of 1,000, which is the same as 250 milliliters. So you can see from the containers that we have there, we have a liter, we have a 500 ml, and I want to remind you that you must have seen that packet of milk that is written 500 ml. That is half a liter. Then there's a smaller one with 250 ml, and that one is exactly half of what we have in 500. Now, moving on, I want us now to look at a sample question. In other words, a sample question is what you need to try and work out to see if you've understood what was at the introduction. So this question is simply for you and I to see whether we have covered something in our introduction. And the question is very simple. Convert 26.4 liters into milliliters. Remember, I have already shown you the relationship between milliliters and liters. And you know now how they relate, that 1 liter is equivalent to 1,000 ml. So this container actually carries 26.4 liters. Can we convert that into milliliters only? Here we go. This is what we do. First of all, we find the relationship. How do they relate? 1,000 ml or milliliters is equivalent to 1 liter. Therefore, if that is true, then what about 26.4 liters? You ask yourself that question. Now, if you want to convert liters to milliliters, what do? You take those liters that you have, then you multiply by 1,000 ml. That is the secret. But if you want to do the other way around, you want to convert now milliliters to liters, what do? You take the milliliters, then you divide by the 1,000 relationship. And that's what you do. For this one here, we're going to multiply 26.4 liters times 1,000 ml. Now, as usual, and you've covered this before, you need not to multiply decimals by other numbers. It's important if you convert that decimal number to a fraction. So with the 26.4, you need to count the number of decimal places, and you realize that after the decimal point, the next number is 4, which is in tenths. So we are going to divide everything by tenths. So 26.4 should be converted to 264 out of 10, which is a tenth. Then you multiply by 1000. And you simply cancel that 10 once, and that 10 to 1000 will give you 100. Now multiply 264 by 100 ml to get a total of 26,400 ml. Once you've done that, you have now the milliliters. You've converted the 26.4 liters to milliliters. And what is the answer once again? 26,400 milliliters. That was a sample question. Now, an example of a question requires that your participation should be higher than what I can do. And here, very quickly, what we can do, and I believe we're going to do the opposite of what we've done in the sample question, and this is converting 2,805 milliliters to liters and milliliters. So we're going to separate this, and we only get liters and milliliters separately. First of all, this is the big container I'm talking about. It has 2,805 ml. We convert this into liters and milliliters, and this is what we do. First of all, the relationship: 1,000 ml equals to 1 liter, 500 ml equals to half a liter, and 250 ml equals to a quarter liter. Therefore, what is 2,805 ml into liters and milliliters? What do we do? I told you, when you are converting milliliters into liters, you need to divide. And this is exactly what we do. We take the 2,805 ml, we divide by 1,000 in the usual way using the long division method, and we consider how many times 1,000 goes to 2,805, and we realize it goes there how many times? Twice. 2 times. So 2 times 1,000 will give us 2,000, and when we subtract, we get 805 ml. 805 ml is actually milliliters on their own, but the 2 we have taken as a quotient become our liters. So what do we have? We have 2 complete liters from the 2,000 ml, and the remaining 805 will be called our milliliters. And the answer is 2 liters, 805 ml. Up to that point, now I want to leave a question for you to attempt. And I'm very sure you are going to try. You're either going to convert from milliliters to liters, or from liters to milliliters. Now, Wambugu bought a crate of soda, that is 24 bottles of soda. Each bottle contained 300 ml. Now, you need to find out how many milliliters of soda Wambugu bought. You can see from the diagrams, a crate of soda. Then 1 bottle that has 300 ml. Now, the next activity that I want you to do is you find out how many liters of soda Wambugu bought. But first, milliliters, and then later on, the liters. And with those very many remarks, I beg to stop there and wish to see you in the next lesson. And for now, it is bye-bye.